So for the last, well, day, we've been factoring for like forever. But today, like on today's lesson, we talked about how to actually find solutions from factoring. So in our notes on finding solutions from factoring, we, if I can find them, which of course I can't, why would I be able to? Oh yeah, so on our notes for factoring, we talked about how we can take a quadratic function, set it equal to 0 because of the zero product property, take out any GCF, factor it, and set those factors equal to 0 to find out what the solutions are. I'm not sure everybody understands exactly why we're doing that, but again, I don't necessarily, you will understand. Someday, this little time bomb we planted in your head is going to go off. It's not going off right now. Don't worry about the why, just worry about the how. To find the solutions by factoring, we set our two factors equal to 0 and solve them. So we factor, set the factors equal to 0 and solve. Okay, so that's what we've been doing. We've been going from a quadratic equation to solutions. So let's do an example of that just so we can kind of remember what that looks like. Okay, I don't see a greatest common factor in this one, so I'm going to just put it in a box and solve it. Okay, so I have A, B, and C. All right, so A, so I'm going to put 3x squared in this box, negative 12 down here. A times C is negative 36, and B is negative 16. So I'm going to do negative 1 times 36, that's a 6, negative 2 times 18, negative 3 times 12, negative 4 times 9, negative 6 times 6. Okay, this adds up to 35, 16, which I'm liking. This is 9, not what I want, 5, not what I want, 0, not what I want. This is what I want, but it's the wrong sign. So if I flip the sign on the 16, that means I got to flip the sign on everything else. So that's the pair that I'm looking for. 2x, negative 18x. And for those of you who are wondering why I'm going so fast, because we've been factoring for days now. You're just going to have to get good at it. Now I take out my GCF here. They have a 3 and an x in common. This one they have a 2, and because this is positive, that one's also positive. Over here they have an x in common. This is negative, and they have a 6 in common. So my factors are 3x plus 2 and x minus 6, and my equation is set equal to 0. So this is the part that we were doing all of last unit. This is the part that we started doing yesterday. So we really only added one step. We take each of our factors and we set them equal to 0 and we solve them. Sorry about that, I'm just checking my own work. X equals 6. So these are my two solutions. All right, so that's what we did yesterday. Okay, that's a quick recap of what we did yesterday. Well, and last unit and yesterday. Now, what we're looking at today is how do I go the other direction? So we went from equation, factoring, we found the factors, and we used those factors to find the solutions. Now we're going to learn how to go back the other direction. So we're going to go from solutions to factored form, multiply it out, so we get a quadratic equation. So let's take a look at that. This is the same exact problem that we just worked on. Okay? So I've got negative 2/3 and 6. What this is, by the way, this is called set notation. That means the set of values. So the two values that make my equation true are negative 2/3 and 6. This is not a coordinate. This is a set of values. That means there's two values that make my equation true. Okay? So the last step here was we had before we did this, we solved the equation, so we solved the factor. So we're going to take this, we're going to turn it back into a factor. So I start by setting them equal to x. So one of my x's is negative 2/3, my other x is 6. Okay, so this one was easy, right? So all I did was, so I want this, instead of equal 6, I want it to equal 0, because that's what I started. I started with it equaling 0. I need it to equal 0 again. So I'm going to subtract 6 from both sides, and that will 0 out. Then I have x, I'm sorry, that was not it. x equals, why do I keep doing that? X minus 6 equals 0. Okay, so there's my first factor. So I went from solution back to factor. Now I'm going to do the same thing here. Well, this is minus 2/3. I want it to be equal to 0. So I'm going to add 2/3 to both sides to zero that out. Now this looks weird, right? X plus 2/3. I don't want to be adding 2/3 to nothing. So I want to get rid of that fraction. When we write our factors, we're not going to have fractional factors, okay? So how do I get rid of a denominator? If you recall from standard form, I multiply everything by that denominator. 3 times x is 3x. 3 times 2/3, that's 3 times 2 is 6. 6 divided by 3 is positive 2. Equals 3 times 0, which is 0. There's my second factor. So notice, I went from solutions back to factored form. Now, I got to multiply it together, but I don't need to factor it. Multiplying is easy. I can either use FOIL, right, because I'm going to rewrite this. Sorry, now it's in factored form, okay, because it's set equal to 0. And now I'm just going to multiply this. You can use FOIL. You can stick it in a box. This gives me 3x squared plus 2x minus 18x minus 12. When I combine my like terms, I get 3x squared minus 16x minus 12 equals 0. So see how I wound up in the same place I started, but I went in the opposite direction, okay? So that's not what you see in your notes, right? What you see in your notes well, hold on, let me see if I can find the crazy nonsense you see in your notes. It's a little scary looking, okay? Oh gosh, where did it go? Oh, there we go, this. Now this is officially how you're supposed to do it, and the reason for that is because you could have an A. This A value right here is a GCF. It's a greatest common factor. So you could have a greatest common factor, but let's pause for a second and let's think about this. Do I need to do that procedure that we just did here? Do I need to do that in order for me to be able to find solutions? Because didn't we learn the easy way to write a quadratic equation? We learned that earlier, right? So I have x-intercepts. X-intercepts of 1 and negative 2. So that means I have a point at 1, 0 and negative 2, 0. And I have a point at 0, 4. Well, how many points is that? That's 3 points. And with 3 points, I can use my calculator. Okay, so with all I need is 3 points. Where in the world did it go? Oh my gosh, I keep losing it. All I need is 3 points to be able to use my calculator. Okay? So this one I could put in my calculator. Now, again, the reason we couldn't do that on this problem, the reason we had to use this strategy is because I only had 2 points. Okay? If I had 3 points, I could have put it in the calculator. Now, what about this one? This one says I only have one x-intercept of negative 1 and a point at 2, 6. Well, today in class, actually yesterday when we did our notes, we talked about an example when there's only one solution. And we talked extensively about what that solution looked like. And what it looks like is when you only have one solution, that solution is the vertex. When you have only one x-intercept of negative 1, that means you have the vertex. And if I have the vertex, I can also find my third point. So I have a vertex, an x-intercept of negative 1, 0, and that's my vertex. I have a point at 2, 6. I have another point that ends in 6. So how do I get from 2 to negative 1? I subtract 3. So if I subtract 3 more, I have negative 4. And with these 3 points, I can go to my calculator and solve. All right? So this process, we do need to understand this process, and we are going to practice it. But remember, don't forget the other stuff we know. We know how to do something with 3 points. Now, if you can't find 3 points, then this is the process that you'll have to use. Okay? But if you can find the vertex and another point, you can use that other point. You can use the symmetrical pair to find the point you're missing. If you have 3 points, you can put them in the calculator and use that to find the answer as well.